testing. This is what I'm going to share with you. What is exactly hypothesis testing? A decision-making procedure. And whenever you do hypothesis testing, you have to do a sample study, you have to do some experimentation. And so whenever we do experimentation, there will be some risk and there will be some error involved, always, right? And what are these risks and what are the errors called? We are going to understand. And in hypothesis, these terminology are very important. Null hypothesis, alternate hypothesis. And then two more tools, very, very important tools. Alpha, the level of significance. P-value, the probability of significance. One of the team is named after alpha, and you will understand what alpha means right now in this session. And finally, there are different hypothesis testing exist. And I'm going to help you understand how to select the hypothesis testing. For a particular situation, ANOVA will be helpful. For some other situation, chi-square test will be helpful. And there are two important categories of testing, test of average and test of proportion. Right, I'll clearly help you understand how to conduct various tests of averages and various tests of proportion. Right, so hypothesis testing means validating the difference. A difference, to be a difference, should make a difference in real life. Then only the difference is difference, isn't it? Otherwise, we don't consider the difference as a difference. For example, after undergoing the training program, and if you are not able to really feel any difference in the way you are solving the problem, do you think you have become a green belt? No, isn't it? So if you really, undergo the transformation, and if you feel for yourself that you are now able to think better, analyze better, and solve better, and offer solution and control the solutions much, much better than how you were doing the same thing before the training program, then the training program is considered to have an impact. Otherwise not. Maybe you could have got a certificate, you could have cleared the exam, but these are all, not going to, validate the skill acquired. What is going to validate the skill acquired? Your real ability to solve problems in real life. And that is what we are also going to check now. And first example, the Maggie case. We all know Maggie was banned in the year 2015. Or 14 or 15, and the reason is the lead content was very high. There is a guideline for certain important things in any food item. For example, lead content is an important criteria as far as food items are concerned. And another thing is a type of salt called MSG, monosodium glutamate. And in Maggie it was mentioned that MSG was not present. I mean, MSG was not added for the sake of bringing the taste. That was a statement given in the Maggie, but actually Maggie was found to have the MSG inside. Another thing is the lead content. According to FSSAI guidelines, there is no permissible level, but Maggie actually had lead content more than the permissible level, and somehow it was made known to the public, and then Maggie was forced to recall their entire product that were available in the retail market. You know how much quantum it was? 38,000 tons of Maggie packets from the retail market was recalled, and all of them were simply burnt, right? And this destroying the 38,000 tons of Maggie packet, this activity was led by the vice president of the company, Mr. Ficara. So what made Ficara, what actually convinced Ficara to burn his own product? If you think, it is nothing but the results found from a sample study. A sample of Maggie packets were studied, and it was found that the lead content is much higher than the prescribed level. And Ficara also agreed it. But how much Maggie packets were burnt? 38,000 tons. If you think about how many packets were studied, do you think they might have studied all 38,000 tons of Maggie packet before burning? No. Just a few number of Maggie packets, 5 or 10 or 20 or at the maximum 30 or 40, just to gain the confidence, that all our Maggie packets will have lead content higher than the prescribed level. Once that confidence is gained, you have to burn all the Maggie packets. So this is called hypothesis testing. This is called hypothesis testing. You take a small sample from the population, study only the sample, and then judge on the population. This is called decision making. You should also be, will be involved in decision making in your job. There may be 3 suppliers who are supplying products to your, maybe supplying raw material to your company. Your boss might expect, may ask you to finalize only 1 supplier, not work with 3 suppliers. Now, who is best out of the 3? This is an important decision you have to make. That's an hypothesis testing. That's an hypothesis testing. And similarly, several situations. There could be 2 departments. Your management would like to know which department is, performing better. This is again another decision-making procedure. That is also an hypothesis testing. In our daily life, every day, we use the tool hypothesis testing. When it comes to the same Maggie case, the name of the hypothesis testing that was used to validate that, all the Maggie packets will have the lead content higher than the, prescribed values. The hypothesis testing used this 1 sample t test. The hypothesis testing used this 1 sample t test. So when to go for the same kind of 1 sample test, for our requirement. First condition, your data should be continuous data. Do you learn? Have you studied the types of data? 2 types of data, all of you studied. Am I right? One is continuous data, another one is discrete data. What is continuous data? Measurable data, right? Lead content is measurable. Lead content is measurable. So the data type is continuous. Whenever your data is continuous, you can use the statistical measure called average. You can use the statistical measure called average. Because lead content, let's say you have taken a sample of 10 packets. All the 10 packets will give you the lead content, 10 readings. And now how will you take a decision? You can't take a decision just by, looking at one value. Since one packet had a higher lead content, it doesn't mean that, the lead content is higher in all the products. But if the average of the sample itself is higher than the prescribed level, it creates, more suspect on the characteristics of the product, right? So whenever your data is continuous, you calculate average and compare the average against the standard value, right? The guideline value. And if the sample average itself is more than the standard value, then you can make a conclusion on the population. What is the conclusion? The entire population will have the value higher than the prescribed level. So whenever your data is continuous, whenever you make decisions, make your decision based on the statistical measure called average. And if you study a sample to judge on the entire population, the study is called 1 sample t-test. Is it clear to all of you when to go for a 1 sample t-test? I'll give a similar scenario for you. Imagine you have a supplier. You have a supplier and you have to audit the supplier. And the supplier is, supplying you a product. Let us say he is supplying you concrete block. And in a concrete block, let us say the strength of the concrete block is very important characteristics for you. The strength of the concrete block is very important for you because you use that concrete block, in your buildings. And if the concrete block strength is bad, then it may lead to, collapsing the entire building, isn't it? So you are going for an audit to your supplier site. Now tell me, will you check each and every concrete block which your supplier is manufacturing?
No, sir. Take a lot.
You will only take a sample
from the lot.
You will only take a sample. Now, tell me, is it important for you to measure the strength of the concrete block correctly? Very important.
Yes, sir.
Now I'm not talking about sampling. I'm talking about measurement. You should know how to measure the strength of the material and measure accurately. Isn't it? And
yes,
if you just take 1 sample, and definitely no, that is not going to be sufficient. Our case is clearly told. Sample means it is not just 1, it is few. You select few samples in such a way that the characteristics what you observe from the sample can be, mapped to the population characteristics. Isn't it? Like the mixture example. When you want to taste a mixture, you take a handful of mixture. Why? because you want to understand all forms of the taste that the mixture is going to give, the sweetness, the bitterness, and everything you wanted to understand. So you see to that the entire composition of the ingredients comes well in your handful size of the mixture, isn't it? Same way, when you take a sample, the sample should be able to grab all possible or all required information from the population. You design such a sampling technique. You go for a surprise visit, nothing wrong. That is also a way of sampling. You go for a surprise visit and then take as many number of samples as required. Let's say they have got two plants, two plants from there, from where they are manufacturing the concrete blocks. You collect some sample from plant number 1 as well as plant number 2, nothing wrong. When you select sample from plant number 1 as well as plant number 2, what kind of sampling technique you are using? You are using a stratified sampling, isn't it? Some plant 1 is the strata, plant 2 is another strata. You don't know how they are doing in plant 1 as well as 2. If you are very sure both are same, then select anyone. But if you are not sure, select some sample from plant 1 as well as sample from plant 2. This is called stratified sampling. But after entering plant 1, again there are so many options, isn't it? Day shift is there, night shift is there. Will you take sample only from day shift or will you take sample from night shift also? It all depends. Maybe you cannot actually go in the night then collect a sample in the night shift, isn't it? So you will collect a sample from only from the day shift. Now your assumption is whatever they do in the day shift, the same thing they do in the night shift also. That's your assumption, right? So this is how sampling works. Ultimately, you need to measure correctly. You need to sample correctly. Measurement error should be less than 10%. We taught you how to measure the measurement error. Another thing is the sampling error should be less than 5%. Why? Then only the confidence, desired level of confidence can be achieved. In the Maggie case, you studied some number of samples till the confidence is arrived. You have arrived on the confidence. The company fellow also agreed on your confidence level. His own product, he also agreed, because you have studied in such a way that the number of sample size, the way you took the sample, the way you actually studied the characteristics, it was quite convincing that Figaro can also agree and then give permission to burn 38,000 tons of the Maggie packet. This is called decision making. This is called statistical validation. A small experiment is done, a small experimental study. A pack of, let's say, 10 samples or 20 samples of Maggie packets were tested in a laboratory, and then based on the results, decision is arrived. So this is how you should also conduct the study. You can do the study to validate anything. You can also validate the root cause. You can also validate your suppliers. You can validate any statement, right? And now, so what is hypothesis testing? Hypothesis testing is a decision-making procedure, a statistical decision-making procedure in which a claim about a population parameter is tested for its trueness using sample data. A claim about a population. My population is good. My population can be bad. Whether it is good or bad, sample will speak about it, right? And that procedure is called hypothesis testing. So it's a decision-making procedure in which the claim about a population is tested for its trueness. And now we are in the analyze phase. We completed the fishbone analysis and we have drawn the impact control matrix, and the first quadrant has 8 factors. And one of the factor is reaction time. It's a chemical process industry. One of the factor is reaction time. And what is that your experts are saying? Reaction time is influencing the chemical process yield. Reaction time is influencing the chemical process yield. For example, your learning time in the Greenbelt training program will have an influence on your skill level after Greenbelt. Am I correct? You learn more here, then probably your level of understanding will be more. I reduce it, at the same time it will be less. At the same time, when I make it too high, maybe again that may not be ideal one. So reaction time in a chemical process needs to be optimized. It should be set at the correct level. Right now, I doubt you are not operating at the right level. This is the expert opinion. Now this has to be validated. Please note, when I say opinion, there is no proof exists. It is a mere opinion based out of my experience, based out of my knowledge level, my limitation. I'm telling you that reaction time, is responsible for the poor yield of the chemical process. And nobody, no one could have, thought about this so far. They never thought that, the reaction time could be the root cause. But right now in the brainstorming, the point evolved, and in the cause and effect matrix that appeared on top of the quadrant. And so that became a candidate for hypothesis testing. Now, reaction time, is it a continuous data or a discrete data? It is a continuous data, isn't it? Whenever it is a continuous data, you run the chemical process several times, measure the reaction time multiple times, calculate the average reaction time, isn't it? And similarly on the other side, we also measure the yield of the process, right? So based on the type of data we are handling, we will classify the testing into certain category, right? There are t-test, there are z-test, and there are ANOVA, and there is proportion test, there is chi-square, and there are several other tests exist, right? And we are going to understand that. Similarly, the next statement, pouring temperature affects casting quality. Pouring temperature, this is, happens in a foundry where they melt the metal and pour the molten metal into a die, allow it to solidify, and then they open the die and take out the casting. This is what they typically do in a casting industry. Now, what is the doubt? All of a sudden, they started doubting the pouring temperature. Last 3 years, they have been always pouring the molten metal at 700 degrees Celsius. And now somebody is telling that you are not pouring at right temperature. And that is why most of your castings are getting rejected. This is how the analysis will go, isn't it? This is how the brainstorming will go. And what so far, whatever you are believing, now somebody will, give a completely opposite picture. And so in order to change your belief, they have to prove it. Otherwise, you will never agree to them, right? So we'll do an experimental study, and then we'll prove, and then we'll convince everybody that pouring temperature has to be modified. And hereafter, don't run the casting process in this manner. Change the pouring temperature from 700 to 723 degrees Celsius. That additional 23 degrees Celsius will considerably reduce your defect issues. And third thing, a sorting time affects on-time delivery. It's a simple case. Sorting process, if the sorting is easier, then deliveries will happen on time. So there are certain, these are all right now are opinion. And all these opinion, they're all fact or not. These are all claims. And each and every claim we need to validate. And for that, we'll do some experimentation on each of this claim. And then we will make a conclusion. And in the previous example, the Maggie case, who did the test? The test was done by a food inspector. His name was Sanjay Singh from Uttar Pradesh. Sanjay Singh is, is external to the company. So Sanjay Singh had access only to the samples that are available in the market. Am I right? The sample Maggie packets that are available in the market, Sanjay Singh was having the access. So based on the available information, he made a conclusion. But the true characteristics of the population will be known only to the company people. Am I right? True characteristics of the population will be known only to the company people. If the same testing is done by a person who has the information about the population, the study will be called Z test, or you can call it G test. So the basic difference between T test and G test is, T means population characteristics are not known because I'm an outsider, or some reason I don't have access to the population characteristics. If the population characteristics is known, then the recommended study is one sample is a test or Z test. Clear? The difference between Z test and T test. When to go for T test? When population characteristics are not known. When to go for Z test? When population characteristics are known. When I say characteristics, I mean only two things: the central tendency and the variation. What is central tendency? The population mean. What is variation? The population standard deviation. If the population standard deviation is known, I will go for Z test. When population standard deviation is not known, I will go for t-test. Is it clear to all of you? When to go for is it test and when to go for t-test. All right. So whenever during the analysis, if a claim is made, the claim can be categorized into two statements, either null statement or alternate statement. You can also call them as null hypothesis or alternate hypothesis. Imagine somebody is asking about, my opinion on all the students who are attending, this particular batch. What do you think, I might tell about all of you? Let us say they are asking about, how good the students are. We want to hire, 5 people from the particular batch of green belts. And what do you think I might tell about all of you? Will I say all the students are, good, or will I say all the students are, they're not good, don't believe them? What do you think I might say? Come on. Will I talk good about all of you or bad about all of you?
Good about all of you.
Generally, we talk good about, if you want to comment about anybody, we'll say no, that because in order to say someone is good, we don't have to prove anything. But when I have to say, hey, this person is risky, then they will ask me, why are you saying like this? Then I have to substantially prove certain incidents. Oh, that is why this person is bad. So certain statement doesn't require any evidence, but certain statement definitely require an evidence. So null hypothesis is a statement for which no evidence is required. People will quickly observe, quickly accept your statement. But alternate hypothesis, people don't believe you. They will question you, with several doubts. So it is very important substantially prove your alternate statement, right? So null hypothesis is always a statement of innocence. A statement of innocence. Everybody will be with you. Our judicial system also work like this, right? The judge will always believe that the suspect is innocent. But if the crime is proved, and then only he will be considered guilty and then punishment will be given, isn't it? So the statement of innocence is null hypothesis. Mathematically, statement of no difference. No difference means equality. No difference means equality. The effect of the statement of equality, the effect before and effect after is same. Or otherwise you can say statement of no effect at all. A factor doesn't have any influence. When you talk like this, these are all called null hypothesis. See, this is very, very important. Setting the hypothesis, writing down the statement. Null hypothesis should be always fall into one of the category. The best statement is statement of equality.
So only one thing.
Yeah, yes, please.
Are we not giving means we are not giving any wrong information because of not having the evidence, something like that?
No. We are
not deviating.
No. See, we have two statements. Both are contradicting each other. Now we are in the process of accepting one of the statement. When I say here, the factor has no effect, then this statement will say factor has an effect. So either I will believe the null or I will believe the alternate. Okay. But what I'm trying to say is how to frame the statement. If you frame the statement in such a way that it is a statement of equality, then it should be named as null and the symbol is H0. Statement of innocence, statement of no change, statement of no difference. These are all null hypothesis, right? And alternate hypothesis. What is alternate hypothesis? The opposite to null. Opposite to null. It is the statement, that has to be, it is the statement that the researcher want to prove. See, everybody knows this, the innocent statement in your company. But in order to make their change their views, you are doing some experimentation, and through the experimentation, you only understood that the alternate hypothesis is true, isn't it? And then by sharing all the information, you will break their belief and accept, make everyone accept your suggestion, right? So the procedure of procedure of taking our decision about the hypothesis is called hypothesis testing. And please note, in hypothesis testing, we are more concerned about the null hypothesis. We are more concerned about the null hypothesis. Either we reject the null hypothesis or we don't reject the null hypothesis. Only these are the two things we can do. Either we reject the null. The moment you are able to reject the null, then your suspect and or your belief on the alternate will become more stronger, isn't it? But all that we are doing in hypothesis testing is we are trying to reject the null or we end up not rejecting the null. In order to gain more trust and confidence on the alternate, you have to do further experimentation. That's a different subject. So far good? All of you are with me?
Yeah.
Very good. And now, a simple case here. A cooking oil manufacturing company, they produced thousands of cooking oil bottle and printed in their cooking oil label saying that the fat content is 15%. So what all of us will immediately think, the entire population in the country, they'll think that the fat content is 15%. Am I right?
Yes.
What everybody is believing, that is called a null hypothesis. So null hypothesis is saturated fat content is 15%. This is why all of us consumed Maggie packet also, isn't it?
Correct.
Even when the lead content was high, we all liked the Maggie very well, and they were their market share was very huge. But the Sanjay Singh could prove it, right? Or in fact could disprove our belief. And the story was one sample t-test. And now imagine you are a dietitian. You are a dietitian. You have hundreds of clients. You are going to recommend this cooking oil to all your clients. And now you want to be very sure that the cooking oil bottle contains only exactly 15% fat content. Exactly 15% means 15% plus or minus some value I am ready to tolerate, isn't it? 15% plus or minus some value I can tolerate. But when they say 15% but the actually is 45%, will you tolerate? We are not going to tolerate, right? So now when I say saturated content equal to 15%, that is the null hypothesis. Then what is alternate? Saturated fat not equal to 15%. Not equal to 15% means it's a two-tailed study. Fat content more than 15% also I am not going to recommend to my clients. Fat content less than 15% also I am not going to recommend to my clients. The study is called a two-tailed. You sometimes study may be one-tailed also. I will be, I'll find it critical only when the fat content is higher on the higher side. If it is lower side, I'm not going to worry about it. But when the saturated fat is more than 15%, I'm not going to recommend the product. Sometimes it can be this side. This is called left-tailed. Hope all of you understand. The hypothesis testing can be two-tailed, can be one-tailed. One-tailed can be right-tailed or left-tailed. And now tell me, saturated fat content, is it a continuous data or discrete data? Continuous data. And now in order to understand whether the cooking oil is recommendable or not, you will take sample of 10 or 20 bottles, isn't it? You will study 10 or 20 bottles. And then whenever you have multiple data, you take the average. Since the data is continuous, you take the average. Now tell me, is the population characteristics is known to you or unknown?
No, unknown, sir.
Unknown.
So what is your test now?
T-test.
T-test. Beautiful. It is one sample t-test. Whenever you come to this situation scenario, please understand your decision-making procedure is called one sample t-test. Suppose if the cooking oil manufacturing company itself is conducting a study proactively because they don't want to risk anyone's life, they themselves study. Now they clearly know, have all the data, isn't it? Last 5 years, whatever cooking oil they manufactured, do you think they will have all the data?
Yes.
Possible. If the data is available, the fat content information is available with them. So far, we have produced, let us say 10,000 units. All 10,000 unit data is available. With the data, will you be able to calculate standard deviation? Yes.
Yes, sir.
If population standard deviation can be calculated, if population standard deviation is known, now you can go for Z test. Z test is more accurate than T test, isn't it? Every day we have the breakfast in our house only because we are preparing exclusively for ourselves. But on a particular day, if we don't prepare, if the breakfast is not prepared, what we do? Then we go for a hotel, isn't it? Same way, whenever Z test is possible, go for the Z test. That means aim for getting the population standard deviation. If you are able to, if you are managed to get the population standard deviation, conduct the Z test, your decision will be more accurate. But for certain reason, if you are denied about the population characteristics, you don't know the population standard deviation, then you can go for the next level of test called one sample T test. Is it clear to all of you the difference between one sample Z test and one sample T test? But both of them will work only with continuous data. Clear? Yes, I need
Yes,
an yes.
sir. Yes, sir.
Very good. Now, there are two vendors who are providing some service to you, to your company. And now you want to cancel the contract with one of the vendor. Then whoever is really, doing well, you will continue working with them. And whoever, not doing up to the mark, you will cancel the contract. And now the decision-making criteria, always criteria is required for making decision. Now the decision-making criteria is transaction time. Every time a particular job is given, how much time vendor A is taking, how much time vendor B is taking to complete the task. Let us say the metric is transaction time. Now transaction time is again continuous data. Transaction time is continuous data. What is your option now? Whichever vendor consuming lesser time to complete the job, you will probably prefer such vendor, isn't it? Am I right? So the vendor with the lower transaction time, you will renew the contract. And vendor with the higher transaction time, you are going to cut the relationship. And if you make a mistake here, instead of renewing, the contract with a good vendor and canceling the contract of the bad vendor, what will happen? You are going to spoil, their business. So your decision is, critical for them as well as critical for you, because you should also complete your work on time and all those things. And now you are studying two groups, vendor A against vendor B. Vendor A transaction time, vendor B transaction time. And whichever transaction time is lower, you will renew the contract, and whichever transaction time is higher, you will discontinue the business. Now the study is called two sample T test. Do you understand the difference between one sample T test and two sample T test?
Right.
One sample is compared against a standard value.
Standard.
But two sample T test is you are comparing two groups, right? And
Wages.
yeah, this is called two sample T test. Let me give an example here. Vendor A, his average transaction time is found to be 14 minutes. How much time? 14 minutes is the average transaction time. Several hundred transactions happen. What is the average transaction time? 14 minutes. And vendor B, the transaction time is 14.02. Now tell me, will you cancel the contract of vendor B?
Yes.
Why?
14.02.
Because it is 14 minutes, this is 14.02 minutes. What's the difference? What is the difference? 0.02 minutes. With this, with such a small value, are you very sure vendor B is worst? Are you very sure to make?
Compared to A, it is worse because the product is too much. Oil, whatever serving.
Okay, whatever it is.
One time.
When the difference is very small, it becomes a challenging job for you.
Yeah.
And particularly your decision is, going to affect the company. You are going to cancel the contract. So you have to be doubly sure, isn't it? You should not take that decision, with a lot of doubt. You should have enough confidence. And that's where the necessity comes to rely on these kind of testing. If the vendor A transaction time is 14 minutes and vendor B transaction time is, 27 minutes, nobody is going to ask you a question. Yes, fantastic, man. You have done a great job. You have done a favor to our company. You have cancelled the contract. That fellow is very worst. I was about to say, but you have cancelled. But when the values are 14 and 14.02, when you cancel the contract and everybody will look at you, with a different angle. Hey, what is this doing? How can he differentiate? Almost both are performing in the same level only. How is he very sure? Now you should have an answer to them. Otherwise, what will happen? You will not be seen as a leader, isn't it? And they will think that you are very bad at decision making. Your decision should never go wrong. You should always have some supporting evidence. Anyway, we will, and that's where another interesting tool comes, p-value. Another interesting tool comes, p-value, which will tell you whether the difference you observed is a real difference or not. Whether the difference observed is actually a difference in real life or not. What is the tool that is going to answer this question? P-value. And we will talk about it little later. And now performance of suppliers. There are 3 suppliers now. Again, your boss is pressurizing you. I don't want to work with the 3 suppliers. I need only 1 supplier. Now, out of the 3, the best one has to be identified. Now, it can be again transaction time or turnaround time or some time or some information. Maybe they are supplying some material, some aluminum or steel material they are supplying. The strength of the material is important. You need a higher strength. Strength is measurable. Time is measurable, isn't it? And so, again, it leads to a situation, but only difference is you are not comparing 2 groups now, you are comparing 3 groups. Whenever the number of groups you compare is more than 2, the study will be called ANOVA. ANOVA stands for analysis of variance. ANOVA stands for analysis of variance. Say, for example, I want to give one of you as the best student award. Best student award with 1 lakh cash prize. Beautiful, right? Best student award. There are 20 people, and whoever is going to score high marks, he is the best student award, and then 1 lakh cash prize. Right? Not just this batch, the entire year. Whoever has topped the batch, and he is going to get 1 lakh rupee. That means what is that I'm doing? I'm doing a ANOVA. Because how many students are here? Right now in this batch itself, there are about 14 or 15 people. At a time, I'm comparing 15 group, trying to find out one best. This is called ANOVA. Your test mark is a continuous data. Right? So there are 3 testing we learned right now. Not 3, 4 testing. What are the hypothesis? 4 hypothesis testing we learned so far? 1 sample. Come on, I want all of you to answer.
Sample.
1 sample is a test.
Yeah, 1 sample t-test.
1 sample t-test. Then ANOVA. 2 sample t-test. What is the commonality you observed? All of them works only when the data is continuous. Very good. And for arriving the decision, you will use the statistical measure called average. Clear? Now, I'm going to help you understand the hypothesis testing connected to discrete data. Right? Let us say, I'm comparing our regular pass percentage. Our regular pass percentage with the Six Sigma certification program is, let us say 90%. How much it is? 90%. But this particular batch, the performance is excellent. Better than 90%. What is the standard so far? 90%. But this particular batch, the performance is, I wanted to say the performance of this batch is the best, compared to our standard. Now, what is pass percentage? Pass percentage means number of people passed against the total number of people. Am I right? 100 people joined the program, 90 people qualified. That means your pass percentage is 90%. 100 people joined the program, but in this batch, 98 people qualified. So my pass percentage is 98%. Now I doubt, we significantly performed well in this batch. Everyone has performed well, the trainer, the participants, everyone has performed well, and that is why the percentage improved from 90% to 90%. Am I correct? Now my concern is this increase in the percentage really due to the performance of the participants and the trainer, or is it a mere fluke? Possibility is there, am I right or not? If it is happened by a fluke, then when I treat this particular batch with some additional rewards, my decision will become wrong, isn't it? But if it is really due to the effort of the trainers and effort of the participant to stand out from the ordinary, then all my efforts and providing the rewards will have meaning, right? And now the pass percentage is a countable data. Am I right? Out of 100 people, how many people passed? 90 people. How do I know 90? I will simply count people who scored pass mark. So it's a 90% means it is not an average, it is proportion. Whenever you work with the proportion, compare a proportion against a standard. What is the standard now? 90%. What is the actual pass percentage now? 98%. And now this comparison is called one proportion test. Do you get my point? See here, this is related to a digital marketing industry. The company believes that generally the digital marketing campaign will give a response rate of how many percentage? 6.5%. And now they hired a new team, new digital marketing team. They have come out with a new strategy. Because of the new strategy they implemented, the response rate has increased to above 6.5%. Let's say it has become 9% or something. Now they have to prove, they have to say, sir, it is because of my strategy, the response rate has increased, above 6.5%. That means, the right-tailed test. The 6.5 is standard value. And how will you verify whether the new campaign has given a additional result? You will again run the campaign for 10 days. Am I right? You run the campaign for 10 days and see how much is the response. And once again, the response is found to be above 6.5%. Now you will start believing on the statement. This study is called one proportion test. Do you all understand what is one proportion? Yes or no?
Yes.
Very good. So next situation. There are two groups I am going to compare. One is male employees, female employees. I wanted to understand whether male employee is performing better or female employee is performing better in my department, right? And I have a data saying the number of defectives or the number of defects produced by male operators, number of defects produced by female operator. My company, was having, belief in the equality. When they hire, they really don't show any partiality. The way they hire the male, the same way they hire the female also. But now there comes a debate. The HR is telling that the female employees are more perfect than the male employees. And so our hiring strategy should change. What should be the new hiring strategy? When we have to hire 10 people, at least 7 people should be female hereafter. Why? Because of the data. And what is the data is saying? Female performance is better. In order to prove, you have to first frame a null hypothesis. Now the null hypothesis will say proportion of male is equal to proportion of female. This is what so far we believed, isn't it? The proportion of defects produced by male is equal to proportion of defects produced by female. This statement is null. But what is that I am going to prove? The proportion of defects produced by male is more than female, something like that. Now it is one-tailed test, right-tailed test. This is called a two-proportion test. Your study can be one-tailed, study can be two-tailed also, depending on the situation, right? And now this is two proportion. Do you understand the difference between one proportion and two proportion? A proportion is compared against the standard. Here, a proportion is compared against another proportion, male and female. Machine number 1 and machine number 2. Supplier A against supplier B. North region versus South region. India against Pakistan. All these situations, right, are two proportion test. Hope it is clear. Suppose if the number of groups are more than 2, Not just 3. In ANOVA also, it can be any number more than 2, 3, 4, 5, 100. Now the situation will lead to chi-square test. All of you understand how to choose the proportion test. Sometimes it is 1 proportion, sometimes it is 2 proportion, sometimes it is chi-square. When to go for chi-square? When the number of groups under study is more than 2 and the type of data using which we take the decision should be discrete data, and the statistics we use for decision making is proportion and not average. Is it clear so far? How many hypothesis testing we got introduced? With the continuous data, how many hypothesis testing?
4.
With the discrete data? 3.
3, sir.
Totally 7. So all of you are alert? Time is
Yes, sir.
4:57. All right. So we have few more things. Now comes. See, if you look at any data, there will be a difference. See, today morning we did some data collection. All of you know, measured the time. But I was always showing, there is a difference. The first reading and second reading, there is a difference. But you told me, sir, difference is very small, isn't it? Let me give an example. Let us say, let us consider the sugar level, a normal sugar level in human body. Human body sugar level. What is the normal sugar level? Can you give me a rough value?
120.
Some range I want.
120
80
to
to
140.
Not 140. 80 to
120.
90 to 120.
Okay, 90 to 120. If 90 to 1, if your sugar level is between 90 to 120, your health is normal. You are not diabetic. Am I right? Let us say one day you wanted to check your sugar level. You are going to a hospital and your reading is showing 120.02. What did the doctor will say? Do you think the doctor will say you have become diabetic?
No, he's
It
saying
will be risk of
control.
diabetic.
to take the control.
Risk of diabetic. You are in the border. Always some border range will be there, right? 121, 122, 123, 124. Still, the doctor will say you are in the border, you are in the border. And for the doctor to conclude, they will have a value. Sometimes what happens, your sugar level goes beyond 135. Goes beyond 135. And that day, doctor will say, congratulations, you have become diabetic. Hereafter, you have to take medicines, right? And your treatment starts from today, right? And hereafter, you should not consume this, you should not eat this and eat that, and all those things they will put. That is how we are also going to work, right? And whether they are correct with their decisions or not, but we want to be correct in our aspect, right? So when you actually collect a sample, you might observe some difference. Now you should not have the question of, you should not have the doubt of being in the border. If the sample characteristics appears beyond the border region, you must conclude that the difference as significant. You get my point? If it is in border, I will not consider the difference as significant. I'll still consider that as insignificant according to statistics. See here, okay, we'll again come to that. And now already I spoke about type 1 error in the morning, manufacturer risk. What is manufacturer risk? A good product is rejected as
Bad product.
product. Imagine your wife is asking you to buy a rice bag, 25 kg rice bag. And you are going to a rice shop or a supermarket or a rice shop. And will you check the rice grains before buying? Obviously, isn't it? You will check the rice grain. So you will take a handful of rice. That means you are doing a sampling. You are doing a sampling. But your bad time, what happened? The sample was so good, but what they have packed is very bad. Based on the sample, you purchased the rice bag and you took it to your house, gave it to your wife started cooking. That moment onwards, your bad time also started, isn't it? So you don't know how to buy a 25 kg rice bag also for the family. And every time, we are cooking and eating the rice, and it is very bad. The quality is, the taste is bad. There were a lot of stones inside. And so you will be getting scolded every time you are sitting for the lunch or dinner, isn't it? All of you could have experienced, isn't it? So that means what went wrong here? Your decision made on the sampling has gone wrong, isn't it?
Yes, sir.
Sample characteristics did not reveal population characteristics. Am I correct or not? This
Yes,
is
sir.
called sampling error. In this particular case, it is type 2 error. This is called consumer's risk, because a bad product reached the hands of the consumer. There has to be a limit for it. There has to be a limit for it, but you just cannot eliminate it completely, because we have to accept, or any sampling comes with the risk only, because you are studying only a limited number of samples, and you are judging on a huge sized population. So there is a risk involved. So this is consumer risk. Other possibilities also there. Next month again your wife is sending you to buy the rice. Rarely they give such opportunity, but it was given to you. And now you will be very strict, isn't it? You will go to the rice shop, and then you might use all your capabilities to check the rice bag now. Maybe you may take multiple sample, am I right? You may even ask them to open the rice bag, am I correct or not? You will do all those things because you had the experience. But in spite of now, since you are now doing a lot of, you have tightened the procedure, you may go to the extent of even rejecting a good quality rice bag. Am I correct?
Yes, sir.
That is, now you are putting the manufacturer under risk because of your sampling procedure, the way you are taking the sample, the method you are following for the sampling, you are increasing the risk of the manufacturer. You are even rejecting a good product. This is called a type 1 error. This should also be, under control. Consumer risk should also be under control, but you just cannot eliminate these errors. Hope all of you will agree with me. If you really want to eliminate the errors, you should go for an 100% audit. Tell me, is it possible to go for an 100% audit for a 25 kg rice bag?
No.
You have to sit down and count every grain. That is not going to be possible, isn't it? Same situation might exist in your work also. There are several occasions where you cannot really check everything. So you have to rely on sampling. And so you should find a way to measure these errors also. Type 1 error and type 2 error. P-value is a tool. P-value is a tool that will give you an estimate of the type 1 error in your sampling study. So what is P-value? P-value is a tool that will give you an estimate of the type 1 error. And most of the time, the sampling study, the type 1 error is very important. They will set a value. Type 1 error should be less than 5%. The permissible level of type 1 error is called level of significance. The permissible type 1 error is called as level of significance. It is indicated by the symbol alpha. So what is alpha? Alpha means level of significance. Generally it is 5%. Generally it is 5%. So p-value will measure the amount of type 1 error. If the estimated type 1 error is more than the permissible level, if the estimated type 1 error is more than the permissible level, we will consider the study as insignificant. Do you understand my point? A study is conducted, someone has conducted the study. He is saying that the difference is there, but I will not trust his statement for the simple reason that the estimated type 1 error is how much? More than 5%. Because the industry standard is type 1 error should be less than 5%. If the type 1 error is less than 5%, indirectly I mean the confidence level is 95%. Because there is a relationship between the error you commit and the confidence level you gain out of the study. If the error is 5%, then how much is the confidence level you are gaining? 95%. Right? Error is a measure of uncertainty. Then the measure of certainty is the confidence level. Whatever you observe, if that is going to happen in real time, 95% of the time, then your confidence level is 95%. Right? Similarly, type 2 error is given the symbol beta. If beta is, let's say, 10%, then remaining 90% is called power of the test. Remaining 90% is called power of the test. I think at the green belt level, if you understand these two, the type 1 error and confidence level, that's good enough. And these are interconnected. See here I have written, your decision to classify whether the study is significant or not, whether the difference is significant or not, is a function of number of samples you collect. More the sample, more will be the trust, isn't it? More the sample, more will be the trust. And number 2, the expected confidence level. And number 3, the power of the test. The number 4, the difference in the statistics to be validated. If the difference is huge, you require less sample. If the difference is very small, then in order to validate, you require more sample. Out of the 4, 3 you can fix. If you fix 3 of the item which I have written in the bracket, the 4th one can be fixed. For example, you want to know the sample size. Then you should decide on confidence level, power of test, and as well as the difference in the statistics, right? And that's how this will work. So probability of significance, p-value. A difference to be a difference should have a difference in real time. Am I right? See, just because you got a difference in the study, it doesn't mean there is a difference. Am I correct or not? Am I right? Say for example, our Sridhar Krishnasamy, he scored 80 mark, and our Gurmeet Singh scored 79 mark. Now what is the difference? 1 mark. Just because Sridhar has scored 1 mark more than Gurmeet, will I be able to say Sridhar has more knowledge than Gurmeet? I cannot say, isn't it? Yes or no?
Yes.
Because it is just 1 test I have conducted, and in that 1 test, the difference is also just 1 mark extra. So this could have happened by a random chance also. This, if it is happened purely because of the knowledge and skill Sridhar is possessing, then my statement is going to be correct. But if it is just by a random chance, then my statement may be wrong. Maybe Gurmeet may be more intelligent than Sridhar. That is also possible, right? So a difference to be a difference should actually make a difference in real life. Don't just believe everything. Six Sigma initially told you that you should be data driven. Now I'm telling you that even if you have a data, don't just blindly believe the data. Ask for the p-value, next level of ceiling. If the data is available, difference is available, at the same time, p-value is less than 5%. Because what is p-value? P-value is an estimate of type 1 error. We want the type 1 error to be below 5%. Then only we can achieve a 95% confidence level. Do you get my point? Yes. P-value is a tool that measures whether the difference observed in an experimental study is statistically significant or not. In order to say whether it is statistically significant or not, you should have the alpha value set before starting the study. Always before doing any sampling study, alpha should be fixed. General value for alpha is 5%. If suppose the process is very critical, for example, your component goes into the aircraft engine, then I will expect higher confidence level. Even 95% is not sufficient for me. I will expect 95%, 99% confidence level. When I expect 99% confidence level, then what is my alpha now? Alpha now is 1%. Right? So before going for the study, this must be fixed. Are you okay with 1% level of significance? Or are you okay with 5% level of significance? If they say they are okay with 5% level of significance, you can understand they are expecting 95% confidence level. So p-value is a tool that measures whether the difference observed in an experimental study is statistically significant or not. If the p-value is less than alpha, study is statistically significant. If p-value is more than alpha, study is statistically insignificant. Generally, a difference is considered statistically significant if the risk of type 1 error is less than 5%. How do you measure the risk of type 1 error? By looking at the p-value. P-value means probability of significance. How to calculate p-value? If you ask me, I am capable of explaining. but you might feel overloaded. So we will teach it at the second level. So p-value, the basic definition is estimate of type 1 error in your experimental study. Based on the data you have collected, p-value will be generated, and p-value is calculated based on your based on the statistic, based on the statistics you have calculated. When you are doing a jet test, you will calculate a statistics called Z score. When we say sigma level is equal to 3 sigma, what is the Z score? Z score is 3. When I say sigma level is 6, what is the Z score? 6. So the Z score is suitably converted into a p-value in a exact test. Similarly, T score will be suitably converted into a p-value in a T test. F score will be suitably converted into a p-value in a F test. Chi-square score will be suitably converted into a p-value in a chi-square test. In all the tests, we are going to convert everything finally into p-value only. So please learn to take decision referring to the p-value. You can handle all the decision making easily. I always take decision only when my p-value is less than 5%. When p-value is less than 0.05, I will reject the null. You know what is reject? What everybody is believing, I will disagree from their opinion. Everybody in the company is believing something, but I will ask them to reject their belief because I have gained enough evidence. How am I sure on that? Because my p-value is less than 0.05. I did an experimentation, and in the experimentation, the p-value generated is less than 0.05. With this information, I am going to request everybody to change their view, change their belief. And this is called rejection of null. If the null is rejected, then everybody will start supporting. Oh, what he is telling, is having some information. He is having, some logic in his decision. But if the p-value is more than 5%, I will not be able to, convince the people around me. If they ask, because the chance for a random chance to generate the data is found to be more than 5%. If the chance for a random chance to generate the data I observed is more than 5%, my confidence level on the experimental study is going below 95%. Under such situation, convincing the people is difficult. And see here, there is a test of mean. You can see what we discussed, right? One sample is a test, one sample T test, two sample T test, and then ANOVA. Similarly, you can see test of proportion, right? Test of proportion, we have one proportion, two proportion, and chi-square. Similarly, you can have test of variance also. What is variance? Square of the standard deviation. And you can compare variance of one group against variance of other group. That's called F test. When there are more than two groups and you are comparing the variance, that is called Bartlett test. And for the same situation, one more parallel test exists, Levin. You can use any one of them. And we are going to use Minitab, and Minitab will handle the procedure of conducting all the tests and throw away the p-value. If the p-value is found to be less than 0.05, you will reject the null. That means you are going to change the belief from what they believed so far to a new one which you have observed. That means the factor which nobody considered as a root cause so far is now going to be considered as a root cause because the associated p-value is less than 5%. Similarly, you can validate relationship also between x variable and y variable. And the relationship between x variable and y variable is linear. This is called correlation and regression. The relationship may be quadratic, may be cubic. And these studies are called correlation and regression study. They are also a form of the hypothesis testing. The thing is, in addition to the validation, they will also give you the exact mathematical relationship. This we will be learning tomorrow morning. So this is all about the basics about hypothesis testing. And if there are any questions, I would love to answer your questions.